Okay, so in number 1, it says fill in the following tables. So, I mean, you really just want to have this first one memorized. So the easy way to do it is with sine and cosine. The denominator of each of these fractions is 2. Okay, now with sine, the numerators go 1, 2, 3. Whereas cosine, they go 3, 2, 1. Okay, it goes in reverse order. And then all of your numerators get a radical. But if you think about this, right, this radical 1, the square root of 1 is just 1. So please don't put it on here. I mean, technically it's equivalent, but we want to write everything in simplest form. So leave this as 1 over 2. Okay, but radical 2 doesn't simplify, so we need that radical. Radical 3 doesn't simplify, so we need that radical. And then same thing with cosine. All right, so as far as tan goes, I always start off right in the middle with tan of 45. That's just equal to 1. And then on either side of the 1, tan of 30 and tan of 60, they both get a radical 3. But because the number 30 has a 3 in it, tan of 30 gets an extra 3 on the bottom. So we put that over 3. Okay, and that's our table. So that should pretty much be memorized. I mean, you want to have those memorized without having to write out the table each time. So that should be clear in your head. All right, so now let's take a look at this table. Now, I know some of you guys have the table memorized, but more importantly, how we get the table is what's important. Okay, I'm going to show this up here. So if we were to draw out the unit circle just goes out 1 unit in each direction. So this is our y-axis, right? And this is our x-axis. So I'm just going to go out 1 unit in each direction, and I'm going to draw a circle. Okay, so since the origin has a coordinate 0, 0, if I were to go over 1, that would be the point 1, 0. Okay, now coming back to the origin, which has the coordinate 0, 0, if I were to go up 1, the coordinates of that would be 0, 1, right? We go over 0 and up 1. All right, going back to the origin, if I were to go back 1, the coordinates of this would be negative 1, 0. Let me just put points on all these so we see these are all points we're putting. And then the coordinates of this point down here, we're going over 0 and down 1. So 0, negative 1. Okay, so this is 0 degrees, 90 degrees, 180 degrees, 270, and then as we wrap back around, we hit 360 degrees. Okay, now this is super easy because as long as you remember that when we have a coordinate x comma y, the x represents cosine of our angle, right? I'm just going to call our angle theta, and y represents sine of our angle, so sine of theta. All right, so since the chart starts with sine, I'm going to start with sine. So again, sine is the y value. So if I want to know what sine of 0 is, I just go to 0 degrees, and the y value there is 0. If I want to know what sine of 90 is, I go to 90 degrees, and the y value is 1. Okay, so we're just going to continue around. So when I get to 180 degrees, the y value is 0. So sine of 180 is 0. At 270, the y value is negative 1. And at 360, the y value is back up here at 0. So to be honest, this chart, I mean, you could memorize it, but it's a good idea to just picture the unit circle in your head and just say, well, what's the y value or what's the x value at that degree? Okay, so cosine is the same thing, except we're looking at the x values. So if you go around the unit circle, I'm just going to go quickly around. The x value is 1, 0, negative 1, 0, 1. Okay, so at 0 degrees, it's 1. At 90 degrees, it's 0. At 180 degrees, it's negative 1. At 270 degrees, it's 0. And at 360, it's 1. So I'm just going to fill in those 5 numbers across my chart. All right, so 1, 0, negative 1, 0, and then back up here at positive 1. Okay, at 360, cosine is positive 1. All right, so now we know, in order to find tan, right, we have to know that formula, that tan is equal to sine of theta divided by cosine of theta, right? Tan equals sine over cosine. So once you have your chart filled out, tan is super easy to find. All right, so we're going to do sine divided by cosine. So 0 divided by 1 is 0. 1 divided by 0, you can't divide by 0, okay? We say it's undefined. That's impossible to happen. I'm just going to abbreviate in here. Okay, and then again, 0 divided by -1 is 0. -1 divided by 0 is, again, undefined because you cannot divide by 0. And then 0 divided by 1 is 0. Okay, so there's our table. Actually, there's both of our tables, and those you have to make sure you have down, okay? Because you have to know really sine, cosine, and tan of all of those angles in order to do a lot of the problems that we do in here. Okay, so let's take a look at the next one. It says, in which quadrant is tan less than 0? So this means that tan is negative. I'm just going to put a negative symbol there. And it says sine is greater than 0, so sine is positive. All right, well, let's think about all students take calculus. Okay, what that means is in the first quadrant, all is positive. All 3 trig functions, sine, cosine, and tan. In the second quadrant, sine is the only one of those 3 trig functions that's positive. Okay, over here in the third quadrant, the T stands for tan. Tan is the only one of those 3 trig functions that's positive. And then in the fourth quadrant, there's a C, which means cosine is the only one of those 3 trig functions that's positive. Okay, so let's start with this. It says tan is less than 0. Tan is negative. Well, we know that tan is positive in 1 and 3, so it's going to have to be negative in 2 and 4. All right, so I'm just going to organize myself. Quadrants 2 and quadrants 4. Okay, then it says sine is positive. Sine is greater than 0. Well, sine is positive in quadrants 1 and 2. So now you just want to look and say, well, which quadrant do they have in common? This one right here, quadrant 2. Okay, so quadrant 2 is our answer. Now, you don't have to show all this work. If you could just look and say, well, where's tan negative and sine positive? Right here. This is the quadrant where tan is negative and sine is positive. So you could just write out quadrant 2. All right, the next one is similar. Here, they're saying that cosine equals negative 0.5. So basically what they're saying is that cosine is a negative number. And then over here, they're saying sine is less than 0, so sine is also a negative number. Now, a lot of you may be able to look and say, oh, look, there you go. It has to be this quadrant. This is the only quadrant where sine and cosine are both negative because tan is the only thing positive there. But if you like to show it your work, that's okay. If you want to write under here, in which 2 quadrants is cosine negative? Well, cosine is positive in 1 and 4, so it has to be negative in 2 and 3. Okay, and then where is sine negative? Well, since sine is positive in 1 and 2, it's negative in quadrants 3 and 4. And then you're just going to again look and see which one do they have in common. And quadrant 3 is the one that both of these have in common. So quadrant 3 is our answer. All right, number 4, determine the exact value of tan of 60 plus cosine of 30. Okay, so tan of 60, if you have to look up at the table above, that's fine. But tan of 60 is equal to radical 3. And then cosine of 30 is a fraction, right? That's equal to radical 3 over 2. So since this is a fraction, let's make the radical 3 into a fraction by putting it over 1. Okay, so when we add fractions, we want to find a common denominator. So my common denominator is going to be 2, which this already has. This doesn't, but all I need to do to get a 2 there is multiply the denominator by 2. And if I do the denominator by 2, we have to do the numerator by 2 as well. All right? So this is going to be equal to 2 radical 3 over 2, and then I'm going to bring down the plus radical 3 over 2. Okay, so now that we have a common denominator, we can add these, okay? When we add fractions, we keep the denominator, so I'm going to keep the denominator of 2. And then when you add these, this is 2 radical 3. I'm going to slide a 1 in here so we can see this. Okay, this is really 2 radical 3 plus 1 radical 3. So if you have 2 radical 3s and 1 more radical 3 altogether, we have 3 radical 3. Okay, and then you would look at your numbers out here and say, do they simplify? But 3 over 2 doesn't simplify, so this is our answer. All right, number 5 is similar, so we're just going to plug in what each of these is equal to. So tan of 45 is equal to 1. And then plus sine of 45 is radical 2 over 2. And since this is a fraction, let's make tan of 45 into a fraction by putting it over 1. So yeah, this is very similar. Okay, so now the common denominator, again, since this is a 2, we can easily make this into a 2 by multiplying it by 2. But if we multiply the denominator by 2, you have to do the same thing to the numerator to keep that fraction equivalent. All right, so that leaves us with 2 over 2 plus radical 2 over 2. Okay, now that we have common denominators, right, we can add them together. So when you add fractions, you're going to keep the bottom, so the denominator stays as 2. And then when you add this numerator, we have a 2 plus a radical 2. There's nothing we could do with those. We can't combine them because this is a radical and this has no radical on it, so they're not like terms. So you're just going to leave it separate as 2 plus radical 2. And then, you want to look and say, well, can I simplify? But really you can't, because even though this is a 2 and this is a 2, the number in front of the radical is a 1. And you would have to be able to simplify all 3 numbers outside the radical, in order to simplify. So this is going to be our final answer for number 5. In number 6, they just want us to figure out how many radians are contained in an angle of 225 degrees. All right, so basically all we have to do is just convert from degrees to radians. And in order to do that, you just multiply by pi over 180. Okay, if it makes it easier, you can put the 225 over 1 and literally just multiply straight across. 225 times pi is 225 pi. I'm going to leave it in terms of pi. The only time you wouldn't leave it in terms of pi is if they said to, round, which means you plug the pi in your calculator. And then 1 times 180 is 180. So again, I'm going to leave it in terms of pi. So the pi is going to still be there in my answer. So I'm going to put that right here. And then all I'm going to do is just figure out what 225 divided by 180 simplifies to. They're both divisible by 45. 225 divided by 45 is 5. And 180 divided by 45 is 4. So it's 5 pi over 4. If you need to use your calculator, you could do 225 divided by 180, math, enter, enter, and it'll give you 5/4. Okay, so we have 5 pi over 4. Number 7 is the same exact thing. So we're going to take 330 degrees and multiply it by pi over 180. And when you multiply across, you get 330 pi over 180. And then in your calculator, you're just going to plug in 330 divided by 180 and hit math, enter, enter. Or if you look at those two numbers, they're both divisible by 30. 33 divided by 30 is 11. I'm going to bring over the pi. And 180 divided by 30 is 6. So we get 11 pi over 6. All right, now it looks like number 8 and number 9, they give it to us in radians, and they want us to convert to degrees. Okay, so in order to do that, we're going to multiply by 180 over pi. Okay, so then what happens is the pi on top cancels with the pi on bottom. And I like to do this in my head rather than in the calculator. It's just good practice to get into. So 180 divided by 6 is 30. And 11 times 30, well, since 11 times 3 is 33, 11 times 30 would be 330. So that's 330 degrees. And that's not the answer. They want to know in which quadrant, right? So 330 degrees is in the 4th quadrant, because that number is in between 270 and 360. All right, then let's see, in which quadrant would an angle rotation of 2/3 pi radians lie in? Instead of writing as 2/3 pi, I'm going to put that pi, right, because technically isn't that pi over 1? I'm going to take that pi and put it on the top with the 2. 2 pi over 3. Okay, this means the same thing as 2/3 pi. All right, so again, if we want to convert to degrees, we just multiply by 180 over pi. And what happens is this pi on top cancels with the pi on bottom. And then I'm going to do this without a calculator again. So since 18 divided by 3 is 6, 180 divided by 3 would be 60. And then we have to do 2 times 60. So since 2 times 6 is 12, 2 times 60 would be 120. All right, so again, we want to know in which quadrant would that be. Well, since 120 is in between 90 and 180, we can say that that's in quadrant 2. All right, number 10. Okay, now in number 10, when I read it, I'm looking at what they give us here. They're telling us we have a circle whose arc length is 48 inches. They tell us it's subtended, and I'll explain what that means in a minute, by an angle of 99 degrees. And they want us to find the radius. Okay, so we have to find the radius. So that being said, I can tell right off the bat we're going to use our formula S equals R theta. Okay, so we have a circle. They're calling it circle O. And it says that it has an arc length of 48 inches subtended by an angle of 99 degrees. So what that means is if we have an angle of 99 degrees, okay, so I'm just going to make this 99 degrees, that extends within this circle, okay, then what happens is this arc length right here is going to be 48 inches. And what they want us to find out is the length of the radius. And they want us to round to the nearest tenth of an inch. Okay, so we know that the arc length is S within our formula. So I'm going to plug in 48. The radius is what we're trying to find, so I'll leave that as an R. And for the theta, remember, it has to be in radians. This is in degrees. So if you take 99, I'm just going to put a parenthesis for multiplication. If you take 99 degrees and convert it to radians, don't we just multiply by pi over 180? Okay, so you could do one of two things. You can either plug this into your calculator and get some decimal, and then in your calculator, right, you could plug in 48 divided by that decimal, or if you want to get the R by itself, you can just divide by this entire thing. I'm going to keep this in parentheses, though, because when you plug it in your calculator, you're going to want to use parentheses. If you do, so those cancel, leaving us with R. If you plug this in your calculator, you're going to want to plug in 48 divided by parenthesis. You want to group this together. You want to take 48 and divide it by this whole thing. Or you could do 48 divided by, and you could use alpha y equals. Here, I'll show you in my calculator. Okay, so if you don't first change this to a decimal and then do 48 divided by your answer, you either have to group this in parentheses, right? You want to do 48 divided by this whole thing, so you put in parentheses to group it, or you could do 48 divided by and just use alpha y equals, so it'll divide it by the whole fraction. Okay, let me show you the wrong way to plug it in. Okay, if you just literally type in 48 divided by 99 pi divided by 180, it's going to do 48 divided by 99 pi and take that answer and divide it by 180. That's not what we want to happen. We want it to do 48 divided by this whole thing. So it's super important that you put parentheses around this or use alpha y equals. Okay, so this one's not right. Okay, anyway, either way, let me move these off to the side. Okay, either way, with these two right ways, we wind up to the nearest tenth getting 27.8. All right, now it's very important that you always put your units. If you leave it like this on a quiz or a test, it's a point off. All right, they even tell you round to the nearest tenth of an inch. So they're saying the units are inches. But even if not, this arc was 48 inches, so the radius would have the same units. Okay, so it's going to be 27.8 inches. And you could abbreviate. You don't have to write out the whole word if you don't want. Okay, number 11, a wedge-shaped piece is cut from a circular pizza that is cut into 8 equal slices. Okay, let me draw that out. So we have a circular pizza, and it's cut into 8 equal slices. I don't know how equal these are, but I'm trying my best. All right, the rounded edge of the crust of the piece measures 4.8 inches. Okay, so I guess this would be the crust right here, and that rounded edge measures 4.8 inches. Okay, determine the diameter of the pizza to the nearest tenth of an inch. All right, so we're trying to find the diameter, the distance across. But in order to do that, what we need to do is we first need to find the radius, right? We're going to use S equals R theta. Okay, well, S is the arc length, which is 4.8. The R is what we're finding. Now the angle, okay, let's think about this. There's 360 degrees in a circle, and we're cutting this into 8 equal slices. So that means each piece has a 45-degree angle, like pointed edge. Okay, now we want to take that and convert that into radians, right? Because theta in our formula is in terms of radians. So instead of just plugging in 45, I need to multiply that by pi over 180. Okay, so again, just like number 10, this is up to you. If you prefer to plug this into your calculator and write it as a decimal, and then, do 4.8 divided by the answer in your calculator, you can do that. If you prefer, it probably is easier to do that than having to do the whole like parenthesis thing in your calculator. That's up to you. But I'm going to just show that I'm dividing by this exact value here, because these cancel, and I'll bring down the R, and then I'm going to just plug this in my calculator as is. But if it's easier for you to do this as a decimal, that's fine. And I just want to point out, you don't have to simplify the 45 over 180 to make it like pi over 4, 1 pi over 4, because you're plugging it in your calculator anyway, and you're rounding, okay? And by the way, they want us to round to the nearest tenth of an inch. So when we plug that in our calculator and round to the nearest tenth, we get 6.1. Okay, now that's the radius. We want to find the diameter. So in your calculator, you want to take that entire answer you see and just hit times 2, right? You want to double it. And when you do, you get the diameter to be 12.2 inches. Okay, so that's the diameter of the pizza. All right, number 12. Looks like the next few we're just determining the exact value, which kind of clues us in as to we're going to have to either use our special angle chart with the 30, 45, 60, or we're going to have to use, our unit circle values with 0, 1s, and negative 1s. So if it helps you to, just kind of like write all your information on your paper and, have everything organized in front of you, if it helps you to do these problems, then do so. Okay, so I put everything off to the side here, but to be honest, this should all be memorized. This should be in your head. This should, if you're prepared for this test quiz coming up, all of this over here should be memorized, okay? But if it helps you, if you visually like to see it, just to, keep the stress off you when you're taking a test or a quiz, that's okay. All right, so number 12, determine the exact value of sine of 135. Okay, so first of all, let's think about this, 135 degrees. 135 degrees would fall in between 90 and 180, so that would put us in the second quadrant. Okay, so if we're in the second quadrant, let's think about it. Is sine positive or negative in the second quadrant? Well, look over here, right? Everything's positive in the first. Sine in the second quadrant is the trig function out of these three that is positive, so sine is positive. Okay, so we're going to rewrite this as positive sine. Okay, not negative sine. Okay, now we have to figure out the reference angle that corresponds with a second quadrant angle of 135. So since we're in the second quadrant, we're using our second quadrant reference rule, 180 minus theta. Okay, so we're going to do 180 minus, well, theta in this case is this given second quadrant angle of 135. And if we subtract those, we wind up getting 45 degrees. So this is our reference angle. This is what we're going to put next to the word sine. So we have sine of 45. Okay, and then that's equal to, you just have to, write down what sine of 45 is equal to. So sine of 45 is equal to radical 2 over 2. And again, it's positive because sine is positive in the second quadrant. Okay, number 13, determine the exact value of tan of 330. Okay, so 330 degrees is in between 270 and 360, so that puts us down here in the fourth quadrant. All right, so we're in quadrant 4. And in the fourth quadrant, we could see over here, right, cosine is the trig function out of the 3 that's positive. So tan is not, tan is negative. Okay, so we're going to rewrite this as negative tan. Okay, so now we have to find the reference angle that corresponds with a fourth quadrant angle of 330. So let me just move this up a little. If we look over here at our reference angle for the fourth quadrant, it's 360 minus theta. So we're going to do 360 minus this fourth quadrant angle. So 360 minus 330, which gives us 30 degrees. Okay, so this is our reference angle. This is what we're going to put next to the negative tan. And, I just want to point out, please, 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 when we say tan is negative, please make sure you're putting the negative in front of the word tan. Don't put it in front of the angle. It's not the angle that's negative. It's this trig function of tan that's negative in the fourth quadrant. Okay, so now let's bring down the negative sign, and then we know that tan of 30 is equal to, that says radical 3 over 3. It's hard to read, but it's radical 3 over 3. All right, there we go. Number 14, determine the exact value of cosine of 150. Okay, so 150 degrees is between 90 and 180, so that puts us in the second quadrant. Now, in the second quadrant, since we're dealing with cosine, we could see right here, sine is the trig function that's positive in the second quadrant, not cosine. So I'm going to say cosine is negative. And remember, on a test, I want you showing all of this work. All right, so we're going to, or, on a quiz as well. Homework, classwork, anything. All right, so we're going to rewrite this as negative cosine. Now let's find the reference angle that corresponds with this given angle of 150. All right, so since we're in the second quadrant, we're using our second quadrant reference angle rule. 180 minus theta. So 180 minus 150, which is 30 degrees. Okay, so I'm going to put that 30 right next to the negative cosine. All right, so let's bring down the negative sign. And then cosine of 30, here's cosine, here's 30, although we should have those memorized, is radical 3 over 2. Okay, and that is our answer. Okay, so in numbers 15 through 17, they also want us to determine the exact value. The only difference with these is these are in radians, so to change to degrees, which we want to do first, right, is we're going to multiply by 180 over pi. So this pi on top cancels with this pi on bottom, and we can see that 180 divided by 6 is 30, and 5 times 30 is 150. So please don't just write 150. This is sine of 150 degrees. Okay, so this is equal to sine of 150 degrees. Okay, so 150 degrees is between 90 and 180, so it's in the second quadrant. We have a lot of second quadrants on this review sheet. So in the second quadrant, let's just show out our work. Since we're dealing with sine, we could see here that, look, there's an S in the second quadrant, meaning that sine is positive. So sine is positive. Okay, so I'm going to rewrite this as positive sine. And then our second quadrant reference angle rule is 180 minus theta. So I'm going to do 180 minus this given angle of 150, which is 30 degrees. Okay, so I'm going to take that 30 degrees and put it here. And since we know that sine of 30 is equal to 1/2, that is our answer. And I just want to point out, the reason why it's so important to show all your work is because I don't want you just, plugging in your calculator sine of 150 and it being, it gives you 1/2. I want you to show that you know where all of this comes from. So please make sure you show all your work if you want to get full credit. Okay, 16, determine the exact value of tan of 11 pi over 3. All right, so we're going to do the same thing. We're going to first change it to degrees by multiplying by 180 over pi. Okay, so this pi on top cancels with the pi on bottom. And then 180 divided by 3 would be 60. And 11 times 60 would be 660. So we can rewrite this as tan of 660 degrees. Now, we always want to form an angle between 0 and 360. So since this is bigger, all we do is subtract off a full circle. We subtract off 360 degrees. If you were given a negative angle, you would do the opposite. You would add on a full circle. You'd add on 360 degrees. All right. So since 660 minus 360 is 300, this leaves us with tan of 300. Okay, so 300, we know, is in between 270 and 360, so that puts us in the fourth quadrant, where tan is not positive, right? Cosine's what's positive there. So we're in the fourth quadrant, do my work off to the side, and tan is negative. So right after I finish writing that, I'm going to rewrite this as negative tan, and let's find the reference angle that corresponds with the given angle. Well, it wasn't the given angle, but with our, angle of 300 degrees. Once you form an angle that's between 0 and 360, this is the angle we're going to be using. Okay, so the reference angle rule in the fourth quadrant is 360 minus theta. So if we do 360 minus 300, that leaves us with 60 degrees. Okay, so all we have to do now is bring down the negative sign, and tan of 60 equals radical 3. So our answer is negative radical 3. All right, number 17 is more of the same, so I'm just going to kind of drag this so we can see the question. Okay, number 17. Determine the exact value of sine of 3 pi over 2. So we are going to multiply by 180 over pi, just like we did with the last two, to change it from radians to degrees. Now, what happens this time? Check this out. So 180 divided by 2 is 90. 3 times 90 is 270. I'm going to just write over here. So this is equal to sine of 270. Now, 270 is one of our quadrantal angles, right? If an angle falls on one of the axes, so 0, 90, 180, basically anything that's a multiple of 90, it's called a quadrantal angle. So we want to use our unit circle. All right, so here's where 270 is. Now, the coordinates at 270, I know this is a little messy. It says 0, negative 1. Well, we're looking for sine of 270, and if you recall, sine is the y-coordinate, right? Cosine is the x-coordinate, sine is the y-coordinate. So if we want to find sine of 270, let's find the y-coordinate at 270, which is, it's hard to say the negative sign, sorry, this is so small, but this says negative 1. So sine of 270 equals negative 1. Okay, so in number 18, they give us sine of A, and they tell us that cosine of A is less than 0, and they want us to use that information to help us find the values of cosine of A and tan of A. All right, now first of all, let's figure out what quadrant we're in. Here, sine is equal to a positive number. So what they're telling us is that sine is positive. Okay, sine is positive. All right, now here it's saying cosine is less than 0. So if cosine is less than 0, they're telling us cosine is negative. So if we think about our quadrants, right? Quadrant 1, quadrant 2, quadrant 3, and quadrant 4, all students take calculus. This means everything's positive in the first quadrant. Sine is the only one of the 3 trig functions that's positive in the second, tan in the third, and cosine in the fourth. All right, so we're looking for where sine is positive. So sine's positive here and here, but at the same time, cosine has to be negative. So this quadrant with the S in it is the only one where sine is positive and cosine is negative at the same time. So we're in the second quadrant. All right, so I'm going to draw the second quadrant triangle. So remember, we always start at the origin and go diagonally out into that quadrant, and you always connect to the x-axis, right, not the y-axis. All right, so there's my triangle, and I'm using an angle of A, so I'm going to put an A in here. Okay, now, let's think about SOHCAHTOA, right? SOHCAHTOA. All right, so we know that sine is equal to opposite over hypotenuse. So this has to be our opposite, and this has to be our hypotenuse. All right, so this is our opposite, and 5 is our hypotenuse. Okay, so if this is our angle, if we go opposite this angle, across from the angle, this is where the opposite would be. So I'm going to put a radical 7 there and label that opposite. Okay, now we also know the hypotenuse is 5, and the hypotenuse is always the longest side. It's always this diagonal side. It's across from the right angle. And now we're going to use the Pythagorean theorem to help us find this missing side. All right, so let's see. We're looking for one of the smaller sides. So we're looking for either the A or the B, and this can go in for either A or B, and the longest side, the hypotenuse, always has to go in for the C. All right, so we'll do, I'll leave it as A squared plus radical 7 squared equals, and this is our longest side, 5, so we have to put that in for C. All right, so A squared plus, when you square a radical, they just cancel each other off, so that leaves you with 7. And then 5 squared is 25. All right, so I'm going to subtract 7 from both sides of the equation. And when I do, sorry, that doesn't look like a 7. I get A squared equals 18. Okay, and then I take the square root. And here, radical 18, it's not a perfect square, but we can break it up. So what I'm going to do is I'm going to break this up into radical 9, radical 2, which gives us 3 radical 2. Okay, so that, I should have left myself more room, but that 3 radical 2 is the adjacent side of our triangle. Okay, the adjacent side always is on the x-axis no matter which quadrant you're in. Whereas the opposite is always the one that goes straight up and down. And the hypotenuse is always the one that goes diagonally out no matter which quadrant you're in. So, it's kind of an easy way to tell. All right, now what they want us to do is they want us to find cosine of theta and tan of theta. So let me start with cosine of theta. Cosine of A, and then tan of A. Okay, now let me just move the page back up because I want to see these SOHCAHTOA formulas. So we know that cosine is equal to adjacent over hypotenuse. But before we write adjacent over hypotenuse, we have to write down whether it's positive or negative. So remember, if we're in the second quadrant, sine is the only one of the original three trig functions that's positive. So it means that cosine and tan both have to be negative here. Okay, so I'm going to put a negative right in front of these. And then we know that cosine is adjacent over hypotenuse, whereas tan is opposite over adjacent. So adjacent over hypotenuse, and tan is opposite over adjacent. Okay, so now I'm just going to look at my triangles over here and just plug in the numbers. So if cosine is adjacent over hypotenuse, well, the adjacent is right here, 3 radical 2. And the hypotenuse is here, 5. I never labeled that hypotenuse, but let me do that now. Okay, so anyway, the hypotenuse is 5. Okay, so there's no radical in our denominator, so there's nothing we really need to change here. Nothing simplifies, so this is our answer. This is what cosine of A is equal to. All right, now with tan, let me bring down the negative. And for the opposite, I'm going to plug in radical 7. And then for A, the adjacent, I'm going to plug in 3 radical 2. Now in this one, there is a radical in the denominator, and we don't want that. So in order to get rid of it, we multiply top and bottom of our fraction by the radical itself. Okay, so that's going to leave us with negative. Now here, these are both under radicals, so we can multiply those numbers. Radical 7 times radical 2 is radical 14. Okay, if they're both under radicals, you just multiply them together. All right, and then here, same thing. Radical 2 times radical 2, we know is just 2, right? So 3 times 2 gives us 6. Okay, and there we go. So we found cosine of A and tan of A. All right, number 19, the terminal side of angle theta in standard position passes through the point 4, negative 8. All right, so let's think about where 4, negative 8 is. If you're thinking about, your x and y axis, I'm going to actually draw it like this because I'm thinking ahead. So if we went over 4 and down 8, 1, 2, 3, 4, 5, 6, 7, 8, that would bring us right here in the 4th quadrant. Okay, so they're saying the terminal side of our angle passes through this point. So there we go. I'm making it into an angle. You don't have to. But what we're going to do is we're going to take that and connect it to our x-axis. And you can see we have a right triangle here. And I'm going to put my angle symbol right in here, theta. Now, we actually, even though they don't come right out and give us 2 sides of the triangle, we know that we had to go 4 units to get from here to here. So the length of this would be 4. And we know we had to go 8 units down to get from here to here. Now, even though we went down, right, even though there's a negative 8, that's just telling us the direction to go. The negative's telling us to go down instead of up. So it's telling us we're in our 4th quadrant. But when you're labeling a triangle, you can't have a negative length on the side, right? So the length of the side of this triangle is just 8. Okay, so now let's again use the Pythagorean theorem and let's find the missing side. Now, if this is our angle, the side across from it is our opposite. Adjacent means next to, okay? This side right here is next to our angle. The adjacent is always on the x-axis anyway. And even though this side is next to our angle as well, this side is the longest side. It's across from the right angle, and it's called the hypotenuse. So the hypotenuse is what we have to find. And when you do the Pythagorean theorem, C is always the hypotenuse. So when we do a squared plus b squared equals c squared, the C is always the longest side. All right, so that being said, we could plug in 4 and 8 for A and B, and it doesn't matter which one you plug in where. All right, so I'm going to do 4 squared plus 8 squared equals c squared. Okay, so 4 squared is 16, and 8 squared is 64. I'll bring down the equals c squared. Now, if you add together 16 and 64, that gives you 80. And now, to get rid of the square, we're going to take the square root. So I'm going to bring down the c. And then radical 80, I mean, the biggest perfect square that divides evenly into it is 16. So I would personally break it up into radical 16, radical 5. And then, I mean, even if you don't find the biggest perfect square, like if you, broke it up, let's say, into radical 4, radical 20, you could, but then you have to break up the radical 20 further. So I recommend just spending the time to see, is there a bit, bigger perfect square that divides evenly into it? Okay, now the square root of 16 is 4. Please don't write radical 4. Square root of 16 is not radical 4. It's just 4. It becomes a whole number. And then you could bring down your radical 5. And that is what our hypotenuse is equal to, 4 radical 5. All right, so what did they want us to find? They want us to find sine of theta. All right, so sine of theta equals. All right, now in the fourth quadrant, right, all students take calculus. Well, sine is not positive in the fourth quadrant. Cosine is. So I'm going to make this a negative. And then if we spell out SOHCAHTOA, I'm going to actually stop there. So sine equals opposite over hypotenuse. Okay, we only need the beginning of the formula for this. So opposite over hypotenuse. And now I'm going to plug my numbers in. So I'll bring down the negative. And in place of the opposite, let's see, opposite, we have 8. And in place of the hypotenuse, that's the side we just found, 4 radical 5. Now we do have a radical in the denominator, which we don't want. So when that happens, you could just multiply top and bottom of the fraction by the radical itself. Okay, so when we do that, on top we have 8 radical 5. You can't put those, you can't make it like radical 40 or whatever, because this is not under a radical, and this is. So you just leave it as 8 radical 5, right? 8 times radical 5 would be 8 radical 5. When they're next to each other like that, it implies that there's multiplication in between them. Okay, now 4 radical 5 times radical 5. Well, we know that radical 5 times radical 5 is just 5, right? So then 4 times 5 would be 20. Okay, now with this one, we actually can't stop here, because when you look at the two numbers on the outside of the radical, you can simplify those. So they're both divisible by 4. I mean, they're both divisible by 2, but you want to find the biggest number that divides evenly into them. So let's do that. So 8 divided by 4 would be 2. And 20 divided by 4 would be 5. So this simplifies to negative 2 radical 5 over 5. All right, number 20. Let's see what we have here. Express the exact value of cosecant. Oh, actually, you know what? That's spelled wrong. I might have fixed it by the time I printed up here, so I'm not sure. Let's just say cosecant of 45 with a rational denominator. Okay, well, when you think about your special angles table, we don't actually have cosecant or, any of those, secant or cotan memorized. What we do memorize is we memorize the reciprocal trig functions, sine, cosine, and tan. Now, since cosecant is the reciprocal trig function of sine, let's first just think off to the side. What's sine of 45 equal to? Okay, well, that's equal to radical 2 over 2. So since they want cosecant of 45, cosecant is its reciprocal trig function. All that means is you take what sine of 45 is equal to and you flip it upside down. Right? Isn't that what you do when you find a reciprocal? So we're going to flip this upside down. So we have 2 over radical 2. All right, so now we want to rationalize the denominator. So we're going to multiply top and bottom of this by the radical itself that's in the denominator. And when we do 2 times radical 2, it's just 2 radical 2, okay? And then on the bottom here, radical 2 times radical 2 is just 2. And this actually simplifies further, because look, the 2 on top cancels with the 2 on bottom, leaving you with just radical 2. All right, number 21. The terminal side of an angle in the terminal side of theta, an angle in standard position, intersects the unit circle at this point. Okay, what is the value of cosecant of theta? All right, so just like in the last one, cosecant of theta is the reciprocal of sine of theta. So if you think about this coordinate, doesn't the x-coordinate always represent cosine? And doesn't the y-coordinate always represent sine, right? So if we know that sine, here I can even put the little theta symbols in there. If we know that sine of theta is equal to negative radical 8 over 3. Since cosecant is its reciprocal trig function, cosecant of theta would be equal to the reciprocal of that. So if you take negative radical 8 over 3 and flip it upside down, you get negative 3 over radical 8. And don't try to get rid of the negative. The negative is still there. If you flip this upside down, you still have a negative. Okay, so now we want to write this with a rational denominator. So I'm just going to multiply the top and bottom by the radical that's in the denominator. And when we do on top, that just leaves us with, you know what, I didn't bring the negative sign over. You know what I can do? I could either put it up on the top or on the bottom, or I'm going to go like this. I'm going to do that, and then it looks like, look, we have a negative, and here's my fraction bar. All right, but anyway, 3 times radical 8 is just 3 radical 8. We can't do anything else with those because the 3 is not under the radical, and the 8 is. All right, and then radical 8 times radical 8 is just 8. And since we can't simplify the 3 and the 8, right, the whole number's on the outside, then this is our final answer, negative 3 radical 8 over 8. All right, number 22, determine the exact value of cosecant of 240. All right, so let's first think about what quadrant we're in. If we're 240 degrees, if we're looking at that angle, that's in our third quadrant. Okay, now, in the third quadrant, right, I'll just write this out down over here. All students take calculus. All right, we're looking at this quadrant, the third quadrant. Now, tan is positive in the third quadrant, and so is its reciprocal trig function of cotan. But we're not looking at either one of those. We're looking at cosecant. So cosecant is negative in the third quadrant. Okay, so what I'm going to do is I'm going to rewrite this as negative cosecant. All right, now we have to find the reference angle that goes along with it. So since we're in the third quadrant, our reference angle rule is theta minus 180. All right, so since our angle is 240, this is what we're going to plug in for theta. So we'll have 240 minus 180, which is equal to 60 degrees. So that's what I'm going to put up here. All right, so, I mean, we don't have memorized offhand what cosecant of 60 degrees is. But if you think about its reciprocal trig function, all right, the reciprocal of cosecant is sine. So let's think about what sine of 60 is equal to. I'll just do this off to the side. Sine of 60 equals radical 3 over 2. Okay, so when I come back up here, let me first take the negative and bring it down so I don't forget about that. And since sine of 60 is radical 3 over 2, cosecant of 60 is just going to be its reciprocal. It's going to be 2 over radical 3. And then just like the last few examples, we want to get rid of that radical in the denominator of the fraction. So when we multiply the top and bottom of this by radical 3, it'll leave us with, on the top, negative, you could put that in front of the fraction, 2 radical 3, right? 2 times radical 3 is just 2 radical 3. So we have negative, and then 2 radical 3 over, well, radical 3 times radical 3 is just 3. Okay, and since the 2 and the 3, there's, you know, they don't simplify at all, this would be our final answer. Cosecant of 240 equals negative 2 radical 3 over 3. Okay, so in number 23, they want us to determine the exact value of cotan of 2 pi over 3. All right, now since this is in radians, right, the first thing we want to do is convert it to degrees. So we know we do that by multiplying by 180 over pi. Because what happens is this pi on top cancels with the pi on bottom. So that is going to leave us with, don't forget to bring the word cotan over, right? Don't just bring the angle over. Cotan of, well, since 180 divided by 3 is 60, 2 times 60 gives you 120. So we're finding cotan of 120. All right, so now let's think about this. So 120 degrees, that's in our second quadrant, right? And in the second quadrant, we have all students take calculus. So in the second quadrant, sine is positive. And in addition to sine being positive, its reciprocal trig function, cosecant, is positive. But we're not looking for either one of those. We're looking for cotan. So in the second quadrant, cotan is negative. So when I rewrite this, I'm going to rewrite this as negative cotan. And please don't try to put the negative up in this step. It's once you change it to its reference angle, that's when you put the negative there. All right, now let's find the reference angle. So the second quadrant reference angle rule is 180 minus theta. So if we do 180 minus this given second quadrant angle, we wind up getting 60 degrees. All right, so I'm going to bring the negative sign down. And then since, you could think about this like in your head or off to the side, but the reciprocal of cotan is tan. And since tan of 60, I'll do this off to the side, since tan of 60 is radical 3, I'm going to put that over 1 because you want to use cotan as its reciprocal. So the reciprocal of this, you flip it upside down, is 1 over radical 3. Okay, that's why I made it into a fraction, so that I could flip it. So the reciprocal is 1 over radical 3. And then we just want to rationalize the denominator. We want to get rid of the radical in the denominator of the fraction. So to do that, I'm going to multiply the top and the bottom by radical 3. So it leaves me with negative, and then 1 times radical 3 is just radical 3. And then on the bottom, radical 3 times radical 3 is just 3. So it leaves us with negative radical 3 over 3. Okay, and then 24, you really start off the same way. They give it to you in radians. So again, we're going to multiply by 180 over pi. So the pi on top cancels with the pi on bottom. And I'm going to rewrite this as secant, pen's not working there, secant of, and don't forget to see this negative sign, don't forget the negative, of, now let's figure out what this is equal to. So 180 divided by 3 is 60, and 5 times 60 would be 300. So secant of negative 300. Now, we don't want a negative angle. So we know when we have a negative angle, we add on a full circle. We add on a full 360 degrees, and see where that brings us. So that's going to leave us with secant of positive 60. Okay, now 60 is in the first quadrant. In the first quadrant, everything is positive, right? So we know this is going to be equal to positive secant. Everything's positive in the first quadrant. And not only is everything positive, but an angle is its own reference angle. So you're going to be using 60 again, okay? You do not have to rewrite this. I was just kind of rewriting it to show you what I was thinking in my head, but you definitely, here, I'll actually erase it so you see you don't have to rewrite that. All right, so now we're just going to be figuring out what secant of 60 is equal to. All right, now secant is the reciprocal of cosine. So let's think about what cosine is equal to. Cosine of 60 is equal to 1/2. So if you take that and flip it upside down, it's just 2 over 1, which simplifies to 2. Okay, so that's it for number 24. All right, and then finally number 25. Okay, and finally number 25. So now let's take a look at what they give us. They give us that secant of x is equal to negative radical 17 over 3. And they also tell us that tan of x is less than 0. So basically they're telling us that secant is negative, right? Because there's a negative in front of that fraction right here, right? It's equal to negative radical 17 over 3. And they're also telling us that tan is negative, because if tan is less than 0, it means that tan has to be negative. All right, so let's think about all students take calculus. All right, now let's start with this. Secant is negative. Since secant is the reciprocal of cosine, technically we're looking for where cosine is negative. Well, since cosine is positive in 1 and 4, it has to be negative in 2 and 3. So it's got to be one of these two quadrants, quadrants 2 or 3. Now, out of these two quadrants, okay, we want to know where is tan negative. Well, tan is positive in the third, but it's negative in the second, so we must be talking about the second quadrant. All right, so let's draw out a second quadrant bow tie triangle. So we go diagonally out into that quadrant, and we always connect to the x-axis to form our right angle here. And then the angle itself goes right between the x-axis and the hypotenuse. So this time the angle is called x, so let's put an x here, and make sure you always label that. All right, now, if we think about our formulas, so ka, toa. All right, so since secant is the reciprocal of cosine, cosine is adjacent over hypotenuse. So that means that secant has to be hypotenuse over adjacent. Okay, it's its reciprocal. It's just flipped upside down. So this would be the hypotenuse, and this would be the adjacent. Okay, so we know that our hypotenuse, the longest side, is radical 17. And we know that the adjacent's always right here on the x-axis. The adjacent is 3. So there's our adjacent. There's our hypotenuse. And the side that we have to find, that we don't know, is the opposite. Okay, I just want to point out one thing. This negative, please don't ever attach a negative to the side of a triangle because you can't have a negative length. The negative is just helping us with which quadrant we're in, right? And because we're in the second quadrant, secant is negative. Okay, so now to find this side, I'm going to do a squared plus b squared equals c squared. Okay, remember the hypotenuse is always the c. So I'll do a squared plus 3 squared equals radical 17 squared. All right, so a squared plus, well, 3 squared is 9. And since a square and a square root cancel each other out, this is just going to be equal to 17. All right, so let's subtract 9 from both sides of the equation. So it leaves me with a squared equals 8. And then when I take the square root, 8 is not a perfect square, but it can be broken up into radical 4, radical 2. Okay, please make sure to put them both under radicals to start. Now, since the square root of 4 is just 2, now we can get it out of the radical and rewrite it as 2 radical 2. Okay, so that's the length of our opposite. All right, so what do they want us to find here? They want us to find sine of x. All right, so I'll do that down here. Sine of x equals, all right, let's think about the sine. Since we're in the second quadrant, sine is positive. So it's going to be positive, and then sine is equal to opposite over hypotenuse. So positive opposite over hypotenuse. All right, well, since the opposite is equal to 2 radical 2, and the hypotenuse is equal to radical 17, we can rewrite it like this. Now, the only problem is we want to get rid of this radical in the denominator of the fraction. So we just multiply top and bottom by this radical itself. So multiplying top and bottom by radical 17. Okay, so now on the top, we have 2 times, well, radical 2 times radical 17. You just multiply the numbers underneath as radical 34. So it gives us 2 radical 34. And then in the denominator, radical 17 times radical 17 is just 17. And then nothing simplifies because 2 over 17 doesn't simplify. And then, I mean, the only 2 numbers other than 1 and 34 that multiplies to 34 is 2 and 17, and neither one of them is a perfect square. So this is our answer.